Hi, my name is Chris. I'm a rising senior at the Bay School of San Francisco, and this is my final project. It is the GPS-controlled car. So basically how it works is you have this GPS module here, which sends data to this Arduino Uno here, which is interpreted by the code, and basically how that would work is GPS sends data, figures out where it is, and then it would also figure out where the waypoint is that it's supposed to get to, which is in the code, and then it would figure out how to get there based on which direction it's facing. The GPS is plugged into this digital pin, which is 0, which is the default RX pin. Then plugged into pin 7, is the servo. So the servo turns the wheels. So once it figures out which direction it's facing, it will turn the wheels the direction it needs to be to end up at its destination. So that's basically how the logic of it works. And then of course power is supplied to the motor. So power is being supplied independently of the Arduino, so once it reaches its destination it just drives in circles, and that's how you know it's there. So major challenges, well, first of all, it was pretty easy getting the GPS to work well and to get readings on the serial board. And it was also pretty easy to get the servo to work, but then getting them to work together was a little bit more difficult. There are a lot of if statements you have to have, and also setting the bounds for the servo. The servo actually has a greater degree of rotation than the steering rack does, so in order to prevent it from binding and possibly breaking, you have to actually set the range that the servo operates in. So I had to do some math to figure out what exactly that was, unless I wanted to just run it until it broke. So that was kind of difficult. I started out on this car, which was in my last milestone video. I got it at Rite Aid, and it basically just drove into a wall and broke. So now I'm on this one. So this is what remains of the first car. So that was another thing, modulating speed. Had some trouble with that, and the steering rack broke off on that. So now on this car, I basically had to redo a little bit of the code because the steering rack was different, the gearing was different. So to just get the speed and the degrees in which the servo would operate required some more coding and some more tweaking of the code. Let's see. So other things that I want to do with this, one of the modifications I did was I added waypoints. So I now have an unlimited amount of waypoints, so I can tell it to go to one location, then go to another, then go to another, and so on and so forth, theoretically, until it just runs out of battery. So in my next steps, I might add a compass to it. I added a compass at first until the compass didn't work. So I have the code for it. And if I get the compass, that'll work, so it'll give you more accurate directional readings, even though it works fine as it is. Having it down to the half of a degree would be awesome. And then reflections. I'd definitely say plan out. I mean, planning was probably the biggest thing that I should have done a little bit better. When I bought the models of RC cars I was going to be using, I didn't know how the servo would mount, which is why there's some weird servo mounting positions. Like here I just had this piece of wood that I super glued on and then mounted the servo vertically. And then on this one it's now mounted horizontally with a VEX chassis piece that I drilled into this chassis. So getting stuff like that to work and getting it to work smoothly and reliably was sort of difficult. Mounting the Arduino was difficult, and figuring out how much voltage you need to send to each component was sort of difficult because these motors actually had different voltages, and running too little or too much voltage will break the motors. So yeah, that's my final project.